Hello, geometry students. Mr. Zacek back and better than ever. Unit 10. Going to be looking at area and perimeter. And some of this at the start is just going to be kind of a refresher, a little bit more in depth, and then some of it will be entirely new as we get to some of the other lessons. So how do we find the area of figures? Well, we know a rectangle is base times height, and in a parallelogram it's also base times height. Here's the deal. The base has to be perpendicular to the height, or the height has to be perpendicular to the base. Sometimes we'll call this altitude, and both of those indicate that it's base times height. So in a trapezoid, the area is 1/2 the height times base 1 plus base 2. For the rhombus and a kite, we get a little more specific in here. We have 1/2 the diagonal times the diagonal. Remember, a rhombus is a parallelogram, so you could also do it using the parallelogram formula, but we've got some special opportunities. Triangle is 1/2 base times height, and a circle is area equals pi r squared. Remember, when we're in the coordinate plane, we can count vertical and horizontal lines, but when they're not, we must use the distance formula to find the sides, okay? Remember, with a circle, we also think of the circumference equals the diameter times pi. Okay, so what's the difference between finding the area and finding the perimeter? Well, area is the space, and it's always going to be in square units, whereas perimeter is a length. And that will just be in units: meters, centimeters, inches, miles, etc. Okay, and so again, for the circle, we have that special formula. The circumference is d pi. So I'm going to jump right into some examples. So a designer needs to create a perfectly circular necklace, and the necklace each need to have a radius of 10 centimeters. So let's sketch a little circle here. So we got a circle, okay, 10 centimeter. That means the other would be 10. Well, the necklace is going to be the circumference. So d pi, which would be 20 pi. So it takes 20 pi centimeters to create one necklace, and we have 1,000 centimeters. So if we take 1,000 and we divide it by 20 pi, I'll just bring that up here. I've actually done that before, so let me clear it out here. So we have 1,000 divided by, and sometimes if you're going to divide it, you might want to put it in parentheses, 20, and then pi, I think in the, not in that one, but in the book one here, we've got pi. Whoops, I did 2 pi instead of 20 pi. So 1,000. I'm going to hit this one, control division. Okay, 20 pi, all right, is 15.9155. So where is my pen? I've got a little board freezing on me. Not a good timing for you, board. Sorry about that. So 15.91. Now, we don't have quite enough to make 16, so we can really only make 15 necklaces there. Okay, moving on. A rhombus has sides 10 centimeters long. So in a rhombus, here's what we know about a rhombus. We know that a rhombus, all the sides are the same. One of the diagonals is 16. Well, we know the diagonals bisect each other and they're perpendicular. So 8 and 8, and we need to find the square. Well, because the diagonals are perpendicular, what we have created here is we have a right triangle. And when we know two sides of a right triangle, I'm going to call this side x, we can do the Pythagorean theorem to find what that other side is. So this would be 64 and 100. So when we subtract 64, we'd get 36. And the square root of that would be 6. So this would be 6 and 6. So if the area is 1/2 diagonal 1 times diagonal 2, then the area would be 1/2 16 times 12. And so let's see what that is. 1/2 16 times 12, I've already done it on here. It's 96. Okay, so the area is 96, and what is it, square centimeters? So we write that as centimeters squared. All right, number 3, find the area to the nearest tenth. Okay, now notice in this question we don't have a like any vertical, any horizontal lines. So one of the techniques that you can do is you can draw a rectangle around this whole thing. And what we can do is we can find the area of this large rectangle, and then we can subtract out the parts that we that aren't a part of this shape on the inside. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So this has a length of 7. 1, 2, 3, 4, 5. 5. All right, so if I do the area of the rectangle, okay, well, that's going to equal 7 times 5, which is 35. Now, what we have here is a number of different, I'm going to highlight them. We've got a number of different triangles. So this would be a triangle. This right here would be a triangle. This would be a triangle. This would be a triangle. And then we've got ourselves a little square up there. So I just need to find the area of those different triangles. So remember, the area of a triangle is 1/2 base times height. And now in all of these triangles, I can count it. So this one already here, if I'm coming down, is 7 and 1. So I have area of the triangle is going to be 1/2 7 times 1. I've got another triangle. Let's do the one on the bottom here. This would be 1, 2, 3, 4, 4 and 2. So 1/2 4 times 2. I've got this little triangle up here, 1, 2, 3, 4, 4 and 1. So area of a triangle equals 1/2 4 times 1. And then I've got the area of the triangle over here. This is 1, 2, 3, 4 and 1. So 1/2 4 and 1. And then we've just got this little square piece. That's just going to have an area of 1, because so the area of the little square is 1. All right, so let's calculate this. So 1/2 7 times 1 would be 7 halves. 1/2 4 times 2 would be 4. 1/2 4 times 1 would be 2. That would be 2. That would be 1. So we can total all of those up. Now 7 halves is really 3.5. So 1 and 2 is 3, 5, 9, 12.5 would be the total of all those non-areas. So what we're going to do is we'll take 35 and we'll subtract 12.5 from it. And that means that the area of ABCD would equal 22.5. Okay, so that's a little technique when you get one of these kind of weird shapes that doesn't quite fit, is you go and you draw a rectangle around it, and then you find the little pieces that aren't a part of it and subtract them out. Okay, we got 2 more. Number 4, what is the area of this trapezoid? So we're thinking area of a trapezoid is 1/2 the height times base 1 plus base 2. So right now we know that base 1 is 7 or 5, base 2 is 7, but we have to find the height. And so here's how we can find the height. We'll draw this down. We'll draw a perpendicular line down here. And what did we just create? That's a 30, 60, 90 triangle. and in a 30, 60, 90, since this was 5 up here from S to R, this would be 5. That would make this distance 2. So what's in our 30, 60, 90? Do you remember our little song? When it's 30, it's A, 90, 2A, 60. What's that? A radical 3. Okay, so A radical 3 means that the height will be 2 times the square root of 3. If you wanted to do this with trig, you could do it with trig as well, doing like the tangent, but if we did it that way, we wouldn't get it in simplest radical form. So it's going to be 1/2 2 times the square root of 3 times 5 plus 7. So 1/2 of 2 is just 1, so it's going to be the square root of 3 times 12, and we would probably just write that 12 in front. 12 radical 3 would be the area of the trapezoid. All right, so one more question. Find the area to the nearest tenth of a centimeter. And I think what we're going to assume here is that this is a parallelogram. Now, this is one where we're going to need to use trig. So if it's a parallelogram, this would be 10, and this would be a perpendicular line. So we have a right angle. So I need to, this is the opposite, and this is the hypotenuse. So if we think of Tom's old aunt sat on her cat and hollered, this is sine. So the sine of 70 equals x over 10. Cross multiply, x equals 10 times the sine of 70. So I'm going to go to my calculator here. I'm going to make sure, back to my home screen, I'm going to make sure that my menu is set in to degrees, and it is set to degrees, so we're good there. Okay, so I need to do 10 times the sine of 70. 70. 9.3969. So x is 9.3969. So that's going to be our height. So area, which is base times height, which would be 8 times 9.3969. So if we've already got that in our calculator, got the answer, we can just do the answer times 8. And that would be 75.1754. 75.1574, I think. So to the nearest tenth, the area would be approximately 75.2 centimeters squared. All right, so just get you started, showing you some of the little tricks, whether it's trig, whether it's a right triangle, special right triangle, this little trick that we have over here in number 3 with the area, the kind of the new thing with the rhombus, and then a perimeter question with the circle. So just kind of give you some of the an idea of the different ways that we can use these tools that we've got in our toolbox to help us solve these problems. So we'll do some more examples in lesson 2, but that'll get you started. So let's get cranking. See you back here soon.